Okay, this is chapter 3.5, talking about proportions and similar figures. So turn to this page in your notes. We're going to take some notes on triangles and how to set up some ratios that we talked about in the previous note pages. Anytime you have notes on triangles, we're talking about corresponding parts in triangles. They are listed in the same order how the triangle is written. So for example, A right here will correspond with X, B will correspond with Y, C will correspond with Z. So the first thing we're going to do is label this triangle as XYZ. So we can see that A and X need to be in the same spot, so I'm going to label that as X. B and Y are in the same spot, so that would be Y. And then C and Z are in the same spot, so this would be Z. So that's the first part, is kind of understand that the letters are in the same positions for similar triangles. The next part in the notes, we talk about similar figures. They have the same shape but not necessarily the same size. So this symbol right here, this little tilde symbol, means similar to, meaning those are the sides that we could compare. So the sides of similar triangles are proportionate. So for example, if I say side AB right here in this triangle ABC and XYZ, that is going to be proportionate with side XY right here. If I look at side AC, that's going to be proportionate with XZ. And if I have side BC or CB, however you want to look at it, that is going to be proportionate with YZ. So I should make this blue so you can see that those are all proportionate sides. We talked about yesterday about scale drawings, how to enlarge or reduce something, usually on a map. You can use ratios or proportions to figure out the actual distance based on a ratio. Alright, so a scale, just for definitions, the ratio of a distance to a drawing corresponding distance. So our first example here, if I have 1 inch equals 10 miles, say on a map, how far would 3.5 inches be? The setup would be this. So I have 1 inch, remember these two little dots are ratios. So 1 inch to 10 miles, just showing how it's written down. That is going to be the same as, we know the inches, so I'm going to put the inches on top. And then we have an unknown for miles. Now when we're setting up these ratios, make sure that whatever your units are, so if an inch is on the top, that the inches would be on the top on the other side. Miles on the bottom, miles on the bottom. If you put miles on the top, then miles would be on the top over here, and so forth. And then we do what we did yesterday. We cross multiply. So we would do 10 times 3.5. So take out your trusty calculators. 10 times 3.5, that gives us 35. So 35 equals, and then 1 times x is just 1x. So in pretty easy setup, 3.5 inches equals 35 miles at that ratio. Here's another ratio that is a little bit more math. If we have say a scale that 2.5 inches equals 10 miles, how far would 8.7 inches be? So always set up with the 2 that they give you. So in this case we have 2.5 inches equals 10 miles, so we set it up as a ratio. So I'm going to label those inches and miles just so I know where I would set up the inches and miles on the other side of the ratio. So we're asking how far 8.7 inches would be. Inches over here is on the top, so we put 8.7 inches on the top. On the bottom is our unknown. We're trying to find miles. So again, we cross multiply. So 2.5 times x is 2.5x. 10 times 8.7, if we type that in our calculator, that gives us 87. And then we would divide by 2.5. This divides out, leaving us with x equals, and then 87 divided by 2.5 gives us 34.8. So 8.7 inches would be equivalent to 34.8 miles. So I mentioned this earlier. It's important to note that when setting up the proportion, the units are on the same side, so the top or bottom of the fraction. Okay, we're going to skip 2 pages. I'm going to go to how to set up a proportion. We talked a little bit about setting up proportions based on triangles, or we talked about how similar triangles work. Actually, let me go back to this page. This is how we would set up a triangle. If these 2 triangles below are similar, give the information to find the length of DF. So we're looking for DF right here, and that is similar to side AC in this triangle. So we know that AC and we know is 14, and we know that CB is 32. So we have 2 parts of a triangle that we know. So I'm going to label that as a ratio. So 14 over 32. Now, 14 is going to be proportionate to DF. So when I set up my second triangle, I need to keep the similar sides together. So if I have basically AC over CB, I have to do DF over FE. So in this case, the 32 and the 24 you can see are on the same side, or on a similar side. So I'll put 24 on the bottom, and my unknown is DF, so I can just call that X. Now we're just going to cross multiply like we did before. 32 times X is 32X. And then 14 times 24 gives us 336. So then I solve for X just by dividing by 32. 336 divided by 32 gives me 10.5. So in this case, X equals 10.5, or DF equals 10.5. So that's how you would solve for a missing side of a triangle. All right, so quick check 3, page 151 for A and B. This is in our green book. I am going to jump ahead to the next page now where I was previously and show kind of how this type of problem works. We were talking about shadows the other day and measuring the height of something that would be really tall, and if the sun's coming at the right angles, casting a shadow, or the correct angle I should say. Here's our sun. We do a smiley face. Use yellow. Yellow sun. Alright, so it's casting a shadow. We know we can measure the shadow on the ground here, so we know that this shadow is going to be proportionate with the shadow of the tree, because if we're standing basically equal distance or in line with the tree. This particular person happens to be 5 feet tall. So we have 2 sides of a triangle that we already know. We know that the base of this triangle is 4 feet and the height is 5 feet. We know that the base of the shadow of the tree is 10 feet and the height of the tree is something that we do not know. That is our unknown. We can call that X. So if you notice here, we have 2 triangles that are similar, 4 and 5. We have another triangle that's bigger but similar. We have 10, and then we have our unknown for X. So we need to set up a ratio or proportion to solve for the missing figure. There's really 4 different ways you can set this up. You need to find one that works for you. We could say, hey, 5 over 4 equals X over 10. We can say 5 over X equals 4 over 10. And there's all those different ways we can do it. I'm going to do like we did on the previous example. I'm going to set this one up as 5 over 4. And that's going to be equal to, now this X corresponds with this 5, so we're going to keep X on the top. And then 4 and 10 correspond. We have 10 over here. So now we can cross multiply like we've been doing. 4 times X is 4X. 5 times 10 is 50. Divide by 4. 50 divided by 4 gives us our answer. 50 divided by 4. You get 12.5. So X, or the height of the tree, equals 12.5. And that would be in feet. Alright, so going back to the previous example, over here you have a tree casts a 26-foot long shadow. So here you can either set it up as like real pictures, or you would set it up as triangles. So we have our tree, we'll just call this our tree, has a shadow of 26 feet, 26. Here's basically our triangle. A boy is standing nearby, so here's our boy, we'll just call this height the boy. He is casting a 12-foot shadow, and his height is 4.5 feet. And again, similar triangles. We're looking for the height of this tree, so we can call that our unknown x. Set up a proportion. 4.5 goes along with x, 12 goes along with 26, so we can set up either 12 over 4.5 would be equal to 26 over x, 4.5 over 12, x over 26. It doesn't matter because we're going to cross multiply, and it'll all work out. So I'm going to set up 4.5 over 12. If I do that, since I listed the 4.5 on top, I have to list x on the top. And on the bottom, you would have to list the 12 is proportionate with the 26. Cross multiply, x times 12 is 12x. 4.5 times 26. 4.5 times 26. It gives us 117. Divide by 12 to get our answer. Gives us 9.7. So the height of that tree is 9.7 feet. Alright, so this is the exact same type of problem. We could set it up. House casts a shadow of 56 feet. So maybe this is the house. This is the shadow. Shadow's going to be on the ground, 56 feet. A girl standing nearby casts a shadow of 7.2 feet. 7.2. The height, they give it to us. Her height is 5.4. Alright, this is our triangle. So we can talk about similar triangles. What is the height of the house? Well, we don't know. Alright, I'm going to set this up a little different. I'm going to set up x over 56. Why not? Just because. So we know that that x corresponds with 5.4. So we put the 5.4 on top. And on the bottom, 56 and 7.2 to go together. So then you'll cross multiply. X times 7.2 is 7.2x. That is equal to 5.4 times 56. So 56 times 5.4 gives us 302.4. We have to get x by itself, so divide by 7.2. So then the height equals, so we divide this by 7.2, 7.2, 42. Alright, use these notes to help guide the assignment for today.